sort of mondish thing that somebody's come up with that
Think
space
we're
time
on, are we?
is
Are we
wobbly
on?
and it's constantly
We're
wiggling
on, yeah.
and wobbling, and
Well,
there's really no
gentlemen,
dark matter, that somehow this wobbling of space produces the rotation curves in the galaxies. And
I
it's
don't
like,
see the little red notation, Mr. President, that we are
yeah,
on
it's
YouTube,
up
are
there.
we?
It's
Up there.
recording. Yeah,
Okay. Well,
We're live.
recording, everybody, and welcome aboard. Hate to interrupt our conversation. We have sometimes more fun off here than we do on with this program. It's our weekly vlog, and we're into year number 4. This is program number 160 of the Santa Barbara Astronomical Unit, down to an acronym of SBAU Astro Hour. I'm Ron Herron, your host, part of the board. We're going to meet the gang here in a minute, and it's all for the South Central Coast longtime astrophysics and now telescope club, the Santa Barbara Astronomical Unit. As I said, I call it 93 million miles of fun in the sun, even though even though we had Saturday night star party canceled and it was a beautiful night. 50 people showed up anyway. I'm going to introduce you to everybody here in a minute, but right now, let's throw a few things at you here as I go off my script. SBAU.org is how you find out all about us. We're going to miss Tom Totten for a while at the end of the month. We're going to have a switcheroo on the second Friday. It'll be our general meeting in April rather than the first Friday. I'm not sure. Are we also switching Saturday star parties?
Yes.
Okay. Well, let's meet the guys who run the club. I'm vice president. Here is the president, Jerry Wilson, to my left, who was the grand patriarch of the weekend, I guess, family reunion. I said you were on assignment. They say that.
Right, we were.
So I expect a full report, Jerry, before this program is over. He's married to Pat Forgy, incidentally, and I haven't seen her in a while, but she's usually with you, comes to the meetings, and a big supporter. We have Chuck McPartland, outreach extraordinaire, who held the post for a while of secretary. That's now being held by Andy Allen and doing a great job. Andy's not with us, but Chuck's married to our merchandise manager and our new treasurer for the new year, Pat McPartland. We have at least most of the top of the head of Tom Whittemore on our screen, who's married to Maureen. Hello, Tom. Oh, my God. Erica's most wanted. Keep your children inside. Tom was married to Maureen, with whom I had a nice conversation outside of the LCO headquarters last week.
Yeah.
And she smelled of sourdough bread. I just love that. Love that cologne.
Yeah.
He's married to Maureen, and now joining us, Tim Crawford, who's married to Karen. Extraordinaire. Are you still involved with the telescope workshop, Tim?
Yes, I go there mostly to listen to people that are incredible astrophotographers.
Oh yeah,
They're putting out results that they're rivaling some of the early Hubble stuff. I mean, Hale telescope stuff. It's unbelievable.
I imagine you hardcore telescope guys enjoyed the Tim Thompson talk about Mount Wilson last month, because he was
very
really
nice.
That was a great talk.
It's excellent.
Yep.
Incidentally, Tim and Tom on my screen logged in a little later than the rest of us and probably didn't hear that we passed a ruling that June's Friday meeting will be moved to the second Friday, just like April. So put that in your memory banks or your computer calendars or whatever, and look at them so you can join us in those meetings, Tim.
Okay.
Okay, is that everybody? I guess we don't have Bruce with us. All right. And a lot of changes coming up. We'll be talking about it in time. We'll try to get a report here on outreach from our illustrious coordinator, Chuck McPartland. Meantime, though, ladies and gentlemen, on the Astro Hour every week, and I can't believe we made it 3 years and we're starting our 4th.
Yeah.
This is awesome.
Wow.
We have a lot of fun. We have a few watchers, if you will, and everything's archived. And we also have the weekly sillies. These are silly science cartoons. They're mostly science that Jerry Wilson forwards to us. And I have them all listed. There's about half a dozen. We'll see if we match up. Ah, yes, right on target. Robbie the robot. What's the origin? Danger, Will Robinson. Actually, they dropped him off, and I guess the mothership is leaving. He's saying, "So long, Robbie. Thanks for all the booze."
Yeah.
Planet down here is all great. And what
Now,
I'm supposed to do now take bit parts in sitcoms.
Which he did. Now, this is from the movie, play on the movie Forbidden Planet from 1953.
I wouldn't call, well, maybe Lost in Space was a sitcom.
It came in the 60s.
Yeah, and it starred the guy that played Zorro for Disney, I think.
Oh, yeah, you're right.
Guy
You're
Roy
right.
Williams.
Okay, well, and there was not a guy inside that suit, was there?
Yes, there is.
Oh, there is a guy, a little midget?
No, a regular full
Really?
human.
Okay.
But in the movie, they took Robbie with them because he was guiding the ship.
Yeah. Well, he can't do a lot with those arms, but that's pretty close to what we got. Okay. This is the chicken's view of which came first. I love this. They're looking at the screen and they're getting a scientific report on which came first, the old guy or the infant. One of the mysteries of the universe, which came first.
And this has the same answer as the chicken and the egg. The egg came first.
Well, something had to come first. I have a feeling it was the grown adult first, Mother Nature or however long ago, but who will know? Thank God for the eggs. All right, this for you dog owners. Happens every time. And again, you know, when they put
That looks like a cat.
He's got to poop in space and there's more debris out there. You dog owners can relate to this. Who has a dog besides the president? Anybody?
I do. We
do.
do.
You have one? Okay.
We have Wally.
And he doesn't do it all over your rugs and carpets?
Oh, no. He's an
dogs-
Australian Shepherd.
Dogs are house trained. Cats are too.
Well, did you house train them or did they come that way?
No,
He actually came that way.
Okay.
Because we didn't get it until he was 7 months old.
We had to work on ours as a puppy.
Okay, I like this one. This is out for a spin. I've always wondered about this in sci-fi movies. The spinning UFOs. What happens to those aliens when they get out of the spinning?
They're all dizzy.
Saucer, yeah. Klaatu and whatever. Okay, this one I don't remember.
Oh, God.
The otter space. Outer space is an otter. Otter space. Why not? After all, we got crabs and bears and rams and tarantulas and Christmas trees,
Look at the
sombreros, and now we got an otter. My God. Constellation, they don't talk. Oh, my God. You ever wondered about Johann Sebastian's Bach? That's what it looked like. We also have pictured Johann Sebastian's front. Question we've always wondered. Okay.
Pretty corny.
All right. This is well, let's say Chicxulub. I got that pronunciation down. The blast that happened down at, I guess,
The Mayan Peninsula.
yeah, all right. One dinosaur's watching the incoming asteroid that killed him. Oh no, the other one goes, this is gonna ruin my day. My God.
Over here on the legend, it has different radii of damage where everything is vaporized. And down here it says glassware damaged. Glass shatters out here on the outer rim. So that's the farthest away. And so that's
part of the
dinosaurs know that.
Okay.
And that's why the dinosaur is worried about his glassware collection.
No, my glassware collection. Okay, Chicxulub and his orchestra. Okay, that's how we did I tell what we're going to talk about? I didn't, did I? We're going to check out Jupiter's icy moon, Europa. There's some strange stuff happening there. We're going to focus the web on a couple of dwarf planets. With the new moon and a blacker sky, look toward Hyades, the Pleiades, Taurus, and maybe M1, the Crab Nebula. Speaking of M's, some people run the Boston Marathon. We like to run the Messier Marathon, and that's underway. We're going to visit Betelgeuse. Way out there, big sucker, and little developing stellar systems that look like galaxies, along with the Drake equation. And that'll be the topic of our next speaker on the second Friday, Dr. Carey from Cerritos College, the race for finding extra planets, extraterrestrials. Where do we start, Mr. President? There it is.
Europa.
Remember this from 2001 Space Odyssey. I think that's the one that the astronaut, Frank Poole, was that his name, was told to look out for Europa, or am I thinking of the follow-up movie?
No, at the very end of 2001,
That's right, with the space
whatever
baby.
was involved in the aliens sent a message. It said, "Stay off of Europa."
And Ron, Dave Carey is from Citrus College, not Cerritos College.
Right.
Oh, you're right. You're absolutely right. He's married to a lady from Chaffee College, but she's not. She may be there, maybe not. Okay, we're looking at a big ice ball. It's more water than our oceans, isn't it?
Yes, the surface doesn't have any craters on it, even though it's out in a shooting gallery type environment. It's all due to expansion and contraction and pressure building up below, created by heat from what is that? Tidal forces inside the icy moon, which melts the ice into water. So there's a saltwater ocean underneath there. They're trying to decide. We're going to send some probes there shortly to try and land on it or measure it or test it. But in the meantime, we've got Juno up there, and Juno has flown close to it. What is it?
200 miles, something like that.
Yeah, something like that. Pretty close. And they've been able to measure oxygen content of the plumes coming out from the water. And there is oxygen there being generated that's coming out. In order to have the life as we know it, the idea is that we have to have oxygenated water, oxygen dissolved in the water. Otherwise, the fishes can't breathe.
But there's anaerobic bacteria, so
yeah, the lower stuff. But you want to, if you want to speculate to higher stuff, and we'll get back to even higher life forms in ocean worlds a little later on in the talk. But the probe says that water is around half to less than half of what was expected from earlier estimates on there. And that brings up, well, we won't go into that. Based on previous estimates, they thought that the water could be anywhere between 11 and 2,425 pounds were produced each second. Now they're down. The new measurements show that between 5 and 1,100 kilograms were produced per second. So it's half of what was, what's that?
Of oxygen.
Of oxygen, yes.
It produces oxygen from the water, it separates the hydrogen from the oxygen somehow.
Assuming what Chuck said, anaerobic processes, assuming the oxygen is like it is on Earth, it's a byproduct because it's very reactive. It's a byproduct of lower forms of life. For example, Earth had no oxygen on it until we got blue algae or something?
Blue-green algae, yeah.
Yeah.
Jerry, what does anaerobic mean? Does that mean non-airy?
Yeah, it means no oxygen.
No oxygen, yeah.
Okay, thank you.
Okay.
But so there's a light atmosphere, but no weather on this sucker, is there?
Though there's no, there is not. There's a very thin atmosphere outside. They're not interested in the outside. This is a close-up view of Europa's surface, showing a lack of craters, maybe some really old craters or punctures here. But this is all pressure ridges and cracks.
Wow.
Things well up in the middle.
It resurfaces itself over short time periods relative to other geological bodies out there. And the reason you can tell that also because it's white ice. And the ice in the radiation environment around Jupiter turns black. So if you look at Ganymede, it's also an icy body, but the ice is much, much darker because it doesn't get renewed the way it does here from getting flexed and cracked and having water ooze up and refreeze.
Oh.
Okay, so this is one of the Galileans.
Yeah.
And it's how does it compare to our moon? Smaller or larger?
Slightly smaller, I think, in the neighborhood of our moon.
And it's got a hardcore rock center, but so it's a very deep ocean. Do they have any idea how far down it goes? Either liquid or
there are some ideas because the Galileo probe went by it several times, though not close, but they measured the gravitational field. And so they have some idea of how deep it is. I don't know the number, but it's deep.
So if there is a collision, an asteroid or a rock, it freezes over. That doesn't leave I see some holes on this picture, but
yeah. But they get erased also by the fact that these cracks well up water from below and then it refreezes. So they get filled in.
Okay. But there's no atmosphere. That oxygen you're talking about, is it released above the
Yeah,
surface?
it's a gaseous form of oxygen,
Okay, but
hovering as an atmosphere, a thin atmosphere.
okay,
I
how
think they
about the
call it an
hydrogen?
exosphere when it's that thin.
But is it part of a mixture that, along with hydrogen and maybe other gases?
Yes, and water. The hydrogen, the oxygen is produced at least partially by radiation from Jupiter, from the environments of Jupiter, because the Jupiter has such a strong magnetic field that it holds radiation in that area, certain areas, and then like the Earth does, and then but Jupiter's much stronger, and then this bombards the surface and it breaks the water molecules up into hydrogen and oxygen.
I don't know how the hell we're going to land on this sucker without melting
Easy.
our way down into the ocean.
Well, the original plan back in the 90s, when we worked on a proposal for it, which was, and there have been several proposals since, but the first one, JIMO, the Juicy Icy Moons Orbiter, was going to land a nuclear reactor on the surface of Europa. And then the reactor was going to melt its way through slowly through the ice layer, and it was going to trail out a long cable behind it, sticking to the surface, which would act like an antenna to broadcast data back to a satellite.
Well, would it
that was envisioned, that was too elaborate, and so it wasn't a go. Other things were higher priority. This one was, the measurements that we're talking about were made by the Jovian Auroral Distribution Experiment, or JADE, aboard the Juno spacecraft, which is orbiting Jupiter right now. And as you know, it goes around in highly elliptical orbits, because one thing that is very susceptible to radiation and damaged by radiation is solid state electronics.
Yeah.
The radiation produces charged damage in the insulators of the circuit elements, and that becomes fixed charge, and so starts changing the bias of resistors and diodes in the circuit, and they start doing things that you didn't plan on, and so their data goes nuts.
So that Juno comes in, what, every 55 days or something?
It's a long
like
orbit.
Yeah.
Longer than that, okay.
No, it's in that neighborhood, like 53 days, 55 days.
How would they measure the gravity? Is it? I mean, they're not dropping a pebble, but are they?
They're measuring the fine position of the spacecraft itself.
Yeah.
It's broadcasting radio waves back, and you can see Doppler shifts as the craft gets accelerated.
Huh. Okay, so it doesn't have anything to do with the gravitational laws. Nothing.
It's exactly the gravitational laws. The spacecraft is the pebble you wanted to drop.
Yeah.
Oh, okay. Okay. Thank you. I was really curious about that.
Okay.
All right. Third of the way through the program, we got a lot to talk about. So
sorry. I won't interrupt.
Just one more point. NASA is planning to launch the Europa Clipper spacecraft later this year in October. It will arrive at Jupiter in 2030, and its primary aim is to estimate whether Europa is a candidate for life or not.
Well, it certainly seemed to have a lot to do with Arthur C. Clarke in his sci-fi.
The volcanoes on Io and these geyser type things on Europa were actually predicted by UCSB astronomer Stanton Peele before they were seen, especially the plumes on Io.
Really?
Yeah.
By LCO? Were they?
No. A UCSB professor before LCO ever existed, back in 1979.
Oh, I got you. All right. Pulled an Einstein on us. So what is this? Is this Io or no? This is
Europa.
Yeah, this is Europa with its icy shell.
Oh.
A rocky mantle inside. The white part is the ice. The blue part is the water. And it has about twice as much water as the entire planet Earth has in this ocean. The Earth is actually a very dry planet. I recently saw a argument on Facebook about Noah's flood, and such a flood would have been impossible because there's not enough water on Earth to flood everything. You'd always have mountain ranges sticking up. So anyway.
I heard that it was the Dardanelles filling the Black Sea from the Mediterranean.
Yeah.
They broke through there.
There were certainly small scale floods in prehistory times that are recorded in legends, and to locals that would have been the whole world, but it couldn't have been a worldwide flood. So anyway, this is hydrogen water coming out. When it gets hit with one of these charged particles that comes down, the hydrogen escapes into space because it's less massive, and the bound oxygen stays around as an atmosphere, and it's this blue haze you see all around it.
The black part, the dark interior, is that a solid core or is that water?
That's rock.
That's rock.
Yes, solid rock.
Okay, got it.
See, there's a blow up here of this section right there.
Oh, maybe.
And the thing they're looking at with what is it? The jade is the transport of oxygen, creation and transport of oxygen, where it occurs. Is it enough? So we'll have to hear about that in the 2030.
And the moon was named, I guess, for our friend, the subcontinent to the east of us somehow, right?
Well,
I don't know where the Galilean moon names came from.
Jupiter's moons are named after lovers of Zeus, of Jupiter.
So Europe got its name from
Europa, yeah.
I got you. Here we are, Drake and its equation. Here we go, folks. This is good stuff.
Yes. Now the article that we're reporting on is the Drake equation, but and we speculated on this at a previous Astro Hour, but there are situations where, as we discover exoplanets, there are situations where it's likely that advanced technologies such as ours, if they develop, are trapped on their planet, or they can't communicate because for example, what we were just talking about, Europa, if there's life in the ocean, then they've never gone out and looked at the stars. So they've never contemplated building space probes because they are stuck inside this ice shell. And the other situation is that we have super Earths that we find out there, which are Earths with up to two times greater than 2 times Earth's mass, up to near the mass of Neptune, which is what, 10 or do you know how much heavier that is than Earth, Chuck?
Boy, it's 4.5 or 5 times the radius of the Earth. So if you take that volume,
cube it,
square it, yeah.
So it's 30 times more massive. So people like that, they probably, if they have developed civilizations and they've developed high-tech civilizations, they certainly have seen the sky, assuming they have clear days on whatever planet they're on. But the gravity is way too much that you can't get off that planet with any form of rocket they could make. The rocket would not, it couldn't get it going fast enough to escape. So space travel and space communications and stuff like that, satellite communications, is impossible. So
might be able to come up with some sort of anti-gravity anti-magnetic or whatever, levitation.
Yeah, that stuff is definitely science. That's in the borderline of fantasy.
Okay.
And it seems to me you don't have to add extra parameters here, because that's kind of in the parameter for a communicating civilization.
Right. And it goes back and forth. I thought the same thing, but proposes that first he calls them fishbowl worlds, where the impetus to develop long distance communication technology is much lower, since messages already travel over vast stretches without having to be amplified with complex text in a fluid environment. Whales communicate with each other very effectively underwater across vast stretches of the Earth. So that would have been a counter effect. If life on a water world was anything like life in our oceans, they probably didn't have hands. So, but maybe octopi. would do just as well.
If they got
Anyway.
if they got intelligent, they'd want to dig out through the ice sheet. I would take the
Right.
shell.
There doesn't necessarily have to be ice for this situation to occur. It just has to be a water world.
Yeah.
Oh, I gotcha. There's a couple of new factors added to that equation, right? Instead of the 7 that are shown, we got 9 now.
That's
No.
It's a proposal.
Yeah, it's just a suggestion from I forgot where they published the paper.
Spain or
yeah, something like that. And so but as Chuck says, it's already folded into terms of the equation.
Okay.
7 equations here. So mean rate of star formation, fraction of stars that have planets. We would change that one to be the fraction of stars that have planets that you can escape from. And this one is unchanged. Fraction of life supporting planets that develop life. No. Fraction of planets where life develops intelligence. Okay. Fraction of intelligent civilizations that develop communication. So this one would be changed, or this one would be unchanged because they wouldn't develop communications. And so basically it would be this one, fraction of stars that have planets you can escape from. So we would just remodify that equation, that definition.
And then the one about the water worlds would be the communication one.
Right, the communication one. So you could put them out there, make it explicit, but it's already implicit in the existing factors.
Well, we're sure going to hear about
some of that. Some of that equation, I think, you just say develops intelligence. I mean, whales and porpoises are intelligent, and I think you should more or less say intelligence that is manipulative or whatever, that modifies its environment, that builds things and does stuff rather than living in it.
That has opposable thumbs.
Well, or something.
Well, though it's a common myth that we're the only animals with opposable thumbs. There are other animals with opposable thumbs.
Well, I hear ravens are pretty damn intelligent. They use tools.
Yes, they do. Number
Lots
of
corvids do. Yeah.
Yeah, I have a lot of respect for those blackbirds.
Right.
Just won't feed them. Maki Maki and his orchestra, and Eris, the third, the second and fourth largest.
Yeah, Ron.
Yes.
Maki Maki is really good with sushi rice, by the way.
That's one of the orders I make at a Chinese restaurant. Sounds like a big long rock that comes through the solar system, except that's Oumuamua. So we know where that came from.
Watch your language.
All right, what do we know? What do we focus the web on these suckers?
Yeah, the web focused on these suckers.
Wow.
And
not in the Kuiper belt.
It's not the high resolution of the web. So these pictures were not taken by the web. I don't think. Well, maybe they were. But no, you don't get this resolution. These are artist impression, obviously. So, but the web offers infrared and deep infrared sensitivity. And with that, you can get spectra in regions where organic molecules and water and stuff has a lot of activity. So for the first time, we have infrared spectra of these planets, of these dwarf planets. And they show that they have water on them.
And methane.
And methane, yes.
Well, certainly the one on the right looks like it's covered with something like snow or frozen water.
Yeah, that's just, they can measure the albedo of it, percentage of light that's reflected. And so they'll know whether it looks white or not. But at this distance from the sun, it's going to be a dark white to your human eye.
Okay, well, if the one on the right, Eris, is the second largest, and the one on the left, Maki Maki, is the fourth largest, where is Pluto in that range? Is it number one?
Pluto's bigger than this. Yeah. There's only one that's bigger than Pluto.
No, I think actually they decided Eris is they thought it was bigger, but it's in the neighborhood, only a
Okay.
tiny bit smaller.
I thought there was another one. Anyway,
Oh, yeah, but
I'm
but
not
it
going
does-
to.
okay, got it.
So they see what is water is coming out as an atmospheric component of these objects. And so they're proposing, these are just all the options. They can't pick between them, but they're speculating that there could be three ways that an ocean world would produce water plumes, as Europa does, and one of the other moons also. But so you can have a localized heat source down here, which is that it's not near another body. So you're not going to get something like Europa where it's around Jupiter and you get convective heating or whatever that is.
Yeah, I can't think of the name. I know what you're talking about.
Tidal friction. Yeah.
Tidal
Yeah.
friction.
Yes.
But now, Mr. President, have you gone back to Europa, or is this applying to the dwarf planets?
No, these are speculations about what would make on a dwarf planet would make a plume that gets water out of an ocean into the atmosphere or into form an atmosphere around the body.
But they're not proposing life might be out there on one of these.
Well, if you've got heat and you've got water.
Yeah, and methane.
And methane.
So
wow. Okay.
Solid state convection.
Yeah, it's like that stuff is a really viscous liquid. Think of it that way.
Yeah.
Okay.
This one, there's a source, localized heat source, but there might be a thermogenic front. There might be a more generalized heat source farther in that produces some flow of heat up here that produces convective water columns or that produces a solid state convection in an ice layer.
Would that be some kind of radiation?
No, that's not radiation, it's just heat. What you see in this white layer, that's the surface of the moon, of the dwarf planet, foreshortened away. Below it is a hypothetical structure. This is an ice shell down to here. Here there's an ice shell down to here. And here it's ice shell all the way down to the rocky core. So that's why here you get solid state convection, where the heat flow up produces some kind of motion in the solid that frictionally heats it up, and you get methane and water spurting out. Here there's a water ocean down below, and it creates a local convection cell that comes up and breaks through the ice. Here they have the localized lava that comes up through the ocean to a thinner ice layer and pushes up. So these are the
and Tim, the source of the heat down there could be radiation. There could be radioactive elements in the core that are decaying and generating this heat. So that's where that thermogenic front could come from when you don't have the tidal friction, or it could be just leftover, molten core from when the object formed.
right.
If you had to guess, Jerry, what do you think is the most likely? B?
Oh, I couldn't tell. I don't know enough about the planet, and I don't think anyone else does. That's why they're offering all their options.
Okay.
So they have proposed this for early to today's Eris for these two, early Makemake for these two, and today's Makemake for these two. So they think, I guess, on Makemake, this stuff may have cooled off by now. Now, back in the 1800s, Helmholtz, I think it was, or one other fellow that was big in thermodynamics, calculated the estimated age of the Earth by claiming that a sphere of dirt that was once lava, and how long would it take that lava to cool off? In classical thermodynamics, this is a tricky math problem, but it's just algebra with math. It's not doesn't need any new physics in it to figure out the solution to that problem. Unfortunately, it doesn't fit the Earth, although Helmholtz thought it did. So he figured out how long it took for the Earth to cool from a lava state, molten state, to its present condition. And he made an estimate that was way too short for the age of the Earth. And the reason it was too short was his calculations were made before they discovered or knew about radioactivity. And as Chuck just pointed out, another heat source that Helmholtz did not consider in the Earth was a generation of heat due to the radioactive decay of elementary or radioactive elements.
But turning lava into dirt over eons of time is done by life, isn't it?
It's done by what?
Life.
No, it's just done by cooling off. You take a piece of lava and put it on your kitchen table. It'll come back a couple of years later. It'll be cold stone.
I thought the worms were working at it and the bacteria and
Ron,
not many
that's like dirt you can use for agriculture, but plain old dirt is just minerals crumbled up.
okay. And on the moon we have lots of dust, and it certainly wasn't made by life. Okay, let's go to the skies, ladies and gentlemen. The Astro Hour visiting M74 right now.
Now M7, this is the season for the Messier Marathon,
right?
Which I believe the optimum time was last Saturday or yesterday, Sunday, but it was optimum. It's where you try to spot in one night, you try to see all 110 or 109 Messier objects. And it's recommended that you start with M74.
Why?
Why?
Yeah.
Still up.
Yeah, you want something that is just about to set to start your evening. So if you wait a few minutes later, M74 is set. Now, we can't do that here completely, or at least it's not recommended because we're north latitude over 34. And it seems to be, Astronomy Magazine represents or says you should be between 9 degrees and 24 degrees north latitude.
And that's just because of the timing this year with it.
Right.
Because of the new moon. And you really don't need a new moon unless you've got a really small telescope to do this. So,
Yeah, and Ron, 74 is a galaxy, so it's even tougher.
Why wouldn't they start the marathon with old one, the crab?
Because you're trying to get all of them during one evening.
Yeah.
So you have to catch the things that are about to set.
Right.
And a quirk of what Messier did is such that in March, all of them can be above the sky in the course of one night.
In the next one, Ron, is 77, which is also a galaxy.
Now, this is M74, as Tom pointed out. It's a galaxy, and this picture contains. This was taken in 2013. It can. Oops, sorry. It contains a supernova down here, which is number 2013 EJ. So
that looks like the whirlpool.
Yeah.
They are very similar. It's a face-on spiral, very perfect spiral, got two major arms. Not like us. We're a barred spiral.
Mm-hmm.
This looks like it has a very, very faint tendency to bar.
Yeah. Is this a Hubble shot?
This is
really amazing.
Doesn't say. Oh, this is European Space Agency. Their Pesto survey captured this view.
Wow.
Yeah, that's nice.
It's a type 2 supernova. Yeah.
I would have thought that the bright blobs were in our galaxy, our nearby stars.
Most of them are.
Yeah.
When you focus in on a distant galaxy, usually there's a star or two in the Milky Way in the middle of things, wouldn't you think?
Yeah, that's what most of these are.
These are stars in our galaxy.
Oh, I thought I just heard you say it was a supernova.
This one right here is a supernova.
In our galaxy?
No, this is a supernova in that galaxy.
Really?
Okay. Yeah.
Okay, we just happen to catch it happening. Don't they go away fast over a few weeks?
No, they took this picture because the supernova was there.
But it doesn't stay like that. It's probably right, doesn't it?
Right, but somebody sees it, and then you aim a big telescope at it.
Yeah,
there's a system worldwide of telegraphs that are sent around to all the major observatories and interested parties, saying just discovered, 70 minutes ago, a supernova, and then they give the right ascension and declination of that supernova. And everybody who's got a telescope looks at it, and they start taking pictures and measure its brightness and spectra over time.
Although now it's more likely text and email than it is telegram.
Oh yeah, that's right. That's right.
Hey, Ron,
That shows my age.
Yes, yes, Tom.
Yeah. Oh, the image you're seeing here has been traveling for 32 million years to your eyeballs.
So that
Ooh,
supernova
okay.
is long gone. It's over. It's now a huge nebula, I'm sure, but we can't see that. Got it. Just amazed.
This is the image that Astronomy Magazine posts as their representative of the Messier Marathon. This is M8, the Lagoon Nebula, and a star cluster in
A
it.
Tim favorite. That's
Yeah,
a Tim.
that one.
It's in Sagittarius. It's up later in the evening. In the summer, it'll be well placed in the evening, and everybody who has photographic equipment will be photographing it.
And that brings up my question that I asked Sandy Seal last week out at LCO, and that is, the photographs, are they single shots that you always take, or do you have a video going?
Both.
Well, I would imagine that to catch an exploding star, you'd have to have a GoPro or whatever the
Ron, video is a very specific thing. So what you do is you take images with a digital camera these days, and you just take image after image after image. Okay. So it's not a continuous analog stream like video is, but you can stitch them together to make the equivalent of a video.
Okay, things move pretty slowly and time-wise in space, right? That's what
Yeah.
you're saying, okay.
Depends what it is.
Jerry, one of the most beautiful views I saw live of the lagoon was up at Kachuma at a camp out with Tim Wittenberg had his 127 out and unfiltered. It was one of the most gorgeous views I've ever seen.
Yeah. And that open cluster there is so pretty. That open cluster in the foreground, it's really
Yep.
good.
Yep.
Yeah.
Okay, okay, this is a nebula or is it a star cluster?
Both.
Both.
And this image that Tim had in his eyepiece, it actually looked like a big little lagoon and surrounded by, some stars in there and then surrounded by some nebulosity. It was just gorgeous.
Yeah, the lagoon part is that dark part in the middle.
Yeah, that's it.
Well, is this the part of your talking points, Jerry, where they're focusing in on little stellar systems being born that look like mini?
I mean, that would be going on in here, but those are mainly from the Orion Nebula.
Yeah.
Oh, okay, guys, sure.
But the lagoon does have some star formation here.
Yeah.
Is this?
Yeah, it's a stellar nursery. It's forming stars. It has formed a lot of stars. But as the stars become stars, they have solar winds like our sun does. And that solar wind is a real wind. It blows things away, and it actually blows the dust away until there's not enough dust to make any new stars. And then you have a star cluster. And then the star cluster starts slowly drifting away because each star is in its own orbit around our galaxy center. There's a project underway now, it's been going on for a decade or more, to try and find the sister stars to our sun so they can put together the star cluster that we came from. And so far, they have about half a dozen candidate stars.
How neat. How neat.
Yeah, we seem to be part of what's called the Ursa Major Moving Association, which includes most of the stars in the Big Dipper and Sirius and Procyon.
Right. Yeah, I was going to mention that.
Not Polaris?
No.
Okay.
So those are the candidates. Interesting.
Among the candidates.
Yeah.
The stellar wind you're talking about, Jerry, it's a combination of particles which don't go the speed of light and light, which does it have any push to it?
Not so much light counting as light does have a pressure. It does push things away. It does alter the orbits of things, but the solar wind is mostly particulates.
So protons?
Protons, yes, primarily protons. Hydrogen nuclei.
Okay.
And electrons too, but not together.
Interesting. Okay.
So if you want to do an experiment for what dirt looks like when it's bombarded by protons, like the moon, or your electrical cables, or bombard them by protons in a nuclear reactor, and you see how they would react left on top of the moon, on the surface of the moon. And in the 60s, or 70s, one of the crews of an Apollo mission went over to a lunar ranger, a lander, and they had bolt cutters, and they cut off a number of cables and parts from the ranger and brought them back to Earth so we could see how our equipment, our materials resisted or didn't the continual proton bombardment. And a lot of things was learned by that. NASA regularly sends up materials and component testing satellites. They're usually just big hollow cylinders with different paints on the outside, different panels painted on the outside, or materials on the outside exposed, and they just want to expose it to the environment for a period of time. And they either bring it back or send something up and observe it. And that's how you get, because you can't, if you have a NASA contract and Congress is in control, they want it to be very low risk. And the only way that NASA will fund putting things up in orbit is if they've demonstrated that they can survive the space environment. So it's like you applying for your first job, and you're 20 years old and they need 20 years of experience, you know. So how do you get your first job with no experience? So they put these satellites up to give a track record for materials and components.
That's like a job I was on. You had to have so many years of experience on the project before you were allowed to work on it.
Right.
So what we would do is, start people off kind of on the periphery, doing stuff slowly, and they'd edge their way in.
Well, I just saw a video saying back in the 60s, they put up a ring around the Earth of little metal filaments that's still up there. I think it goes over the poles. And they put it up so it would bounce radio waves back to Earth. And they tried to go. And it's still up there among the debris.
But that wasn't, I think Echo wasn't filaments. It was just like a big Mylar balloon. It was like metallized balloon that you would bounce signals off of.
Well, according to the video, the balloon didn't work as well until they got a million little filaments, little strings of.
Boy, that's bad news now.
Yeah, I haven't heard the filament one.
I was going to say, BFI, get busy.
Okay, this is M30 and is the recommended ending Messier object because it just comes up before the sun early in the morning. So if you dawdle, you have to put your telescope away because you don't want to see the sun. It's located in Capricornus.
It's a globular. Yeah.
This is what it looks like to Hubble.
Mm.
And in a Messier marathon early in the morning, all you see is a little bit of haze.
Yeah.
Do you guys doing the marathon have to check in and prove that you saw everything?
No. It's the honor system.
Oh, okay.
Now the Messier marathon was a bigger deal and more of a challenge before computer operated go-to telescopes, because now you have your telescope set up and you just tap in, go to M30, and then the thing goes, there it is. In earlier times, you had to do what Tim and I like to do, and other people too, is star hop from visual to visual thing and try and find it yourself.
And that gets tough when the sky's bright.
It's fun though. It's fun.
Yeah. You learn the stars that way.
Yeah. Mm-hmm. We had back at a Messier marathon in, I think, 2002, we had a guy who had a computerized scope, and he was trying to do a photographic Messier marathon.
Okay.
Oh, wow.
So he was trying to get an image of every object.
Wow.
Well, I'm sure old man Messier did this over his lifetime. He didn't take in, name 4 or 5 things in a night. But,
right.
I'm wondering if his telescope had any tracking back in those days.
It had a universal tracker.
And holding it in his hand. Okay.
Actually, no, they did have trackers in those days, but it would be something where you would, like with a grandfather clock, where you would raise a weight, and the weight would gradually come down and turn a bunch of gears, and then that could turn your telescope. But I don't think he even had that, but it was available.
Was that Bob Piontek?
No, it was pre-Bob.
Oh, okay.
I don't remember the guy's name, but he was a good guy.
Unitron used to sell falling weight tracking systems for when you want to use your telescope out in the woods. No electricity. The moon was new yesterday, last.
Okay.
And so we're going to see now in the evening sky, we're going to see a thin crescent, a waxing crescent. And it's an opportunity to look at Earthshine.
Mhm.
This is light on the dark side of the moon that's reflected off of the Earth. At first, it was thought to come off the oceans, but it now is known to come off of clouds and snow and poles primarily. But it shines up, and you can see the backside of the moon to some extent.
Mhm.
This the sunshine part is much brighter, of course, and you don't get the two together. You have to take two pictures at different exposures and then add them together to get a.
My watch says that we're tonight visible as 2%.
Yeah, this is a much higher than 2%. 2% is just a very thin line.
Little sliver.
Yeah, and there is a challenge that some people take about trying to get the earliest, the thinnest photograph, the thinnest crescent you can get.
Yeah.
They are very, when I've seen winning photographs in that contest, they are very, very thin things.
Yeah.
Hairline moon.
Yeah.
And the Earthshine, I've seen Earthshine, it's just incredible.
Mhm.
Even
And
more
this is also the time of the year, because we're coming up on the equinox, that the moon gives you a smile.
Yeah.
Yeah,
Gives you a
yeah.
smile.
And speaking of the equinox,
Mhm.
the vernal.
yeah, it's the first point of Aries, except it's in Pisces now.
Yeah.
So this is the constellation of Aries. It looks just like a ram.
Yeah.
So the it's down here. Jupiter's the easiest thing to spot. Jupiter's much brighter than Hammel. But
There's actually one more star in it, technically, Jerry.
Where, this one?
No, go out. Think of the thing pointing to the left and up. Go up and get the bright one right there.
Okay.
So technically, that is part of Aries.
Do you know the name of that one?
No, I don't. I don't remember it.
And I've never heard of Ari there, that one star. I thought that was Mesarthin.
Yeah,
Okay.
that's what came. Mhm.
Well, it could be.
I mean, some of these have multiple names, so
Yeah.
Yeah. No, it could be something that's cut off. By the way, I added these names.
okay.
Oh, okay.
So yeah, everybody goes, oh, okay, well, now we know where. No, but I did look them up, and because this one wasn't named in the planetarium software I used, that's the name they gave, but it might have been at the edge of a picture that I looked at, and then part of it was cut off. So
Somehow there's a ram in there.
yeah, it takes a lot of imagination.
That's
Yeah.
his head and his horns on the right, and that's pretty much all you see.
Yeah.
Okay, I see Uranus, I think.
Yep, Uranus was in there, not as bright as, but the first point of Aries is where the ecliptic crosses the celestial equator, and it defines the origin of right ascension and declination. And due to precession of the Earth's orbit, it has moved now to Pisces. You can see that the first point, this is the symbol, astrological symbol or something for Aries, the ram.
Mhm.
It looks more like a ram than the stars do. And you can see now it's in Pisces, but it used to be in Aries 1,000 years ago or so.
Okay, I figured out where you got the ARI.
Okay, where?
That was actually probably the label for the constellation, which is
Yeah.
ARI for Aries.
Yeah, could have been.
Yeah, because it's Mesarthin.
Yeah.
Yeah.
Well, that looks like a divining rod on top of it.
Yeah.
When I put the cursor on that star in the planetarium software, it gave me an HD number. It wouldn't give me the name.
Oh,
So I went online and looked it up. Okay.
HD for high def.
No.
Henry Draper.
Henry
Oh.
Draper.
Okay, now this is very interesting. First of all, as someone remarked earlier about high quality images that are taken by amateurs, there's a number of really, really good new software that's coming out that has taken a giant leap forward in the ease of processing these things based on AI. And people are still trying to figure out how some of these software programs achieve what they do, but they're just phenomenal. But one of the older formulas that worked very well was called a rotational gradient removal. And so that goes through and it takes out everything that's spherically symmetric in a picture. And this is simple subtraction of everything. There is also the Larson-Sekanina filter, well known to people that do image processing. And this is that stuff, that kind of filter applied to Comet Lovejoy in 2013. And it shows there's the image of the comet. And here it is with everything that's spheric, the brightest stuff that's spherically symmetric removed. And it brings out the underlying non-spherically symmetric structure. So you can see jets coming out of the comet head that you would not normally find in this picture. And this is it for Comet Pons Brooks, which is currently up. And this is a picture you'd take, and this was with that filter applied. And you can see the actual, it gives you you can see a little bit of the veins going out, but this gives you a clearer picture of things going out.
Wow.
So it's an image processing thing. This is done by a Frenchman, Robert Cazelat, and does a lot of work on and posts it on Facebook.
Well, do you suppose this is similar to the technology that gets rid of the wiggling of stars in your telescope through the atmosphere?
No, this is not adaptive optics. This is, you take a picture and then later, next week you bring the picture up and you apply this filter to the picture. Adaptive optics is done in real time because the atmosphere is wiggling in real time.
Somehow it can take away the round part that it's not needed and leave the stuff that's right in
Well,
there.
it's much brighter, and so it obscures, it brings out patterns that are more difficult to find. So you can see flows of material in there.
Okay.
One time someone looked at, you guys may know this better than I do, but someone looked up at the sky and claimed that we'll never know anything about the stars because the only thing we have from the stars is their light.
Yeah, it was the philosopher Lecomte.
Okay.
That was the guy, yeah. And then spectroscopy was discovered.
Right. He was feeling a right fool.
And we couldn't look at infrared back then, right?
No, we didn't even know there was infrared.
Right.
It was Herschel that discovered infrared.
Yeah.
He's the guy that put the thermometers by the
by
rainbow.
the prismatic spray,
Yeah.
Was William the older one was John, right?
No, William.
No.
William
John
was
is
the
his
older.
son.
William Herschel.
Okay, so William worked with Carolyn.
Yes.
Yes.
Okay.
It's a sister.
And these are not galaxies we're looking at, are they?
These are proplids.
What?
Proplids, protoplanetary disks.
Yeah.
Oh, so they're like developing solar systems or stellar.
Right. Now these are radio telescope images taken by the Very Large Telescope Array in Chile.
Wow.
And
Wow. 6 different ones?
these are 6 different ones.
Okay.
These are,
Oh, they're in different constellations too.
Yeah.
Not all in Orion.
Well, obviously it's in our galaxy.
no, these are in our galaxy.
Yeah, right. Obviously.
Yeah.
This is a larger collection of them.
This
Wow.
is part of your presentation that goes way over my head.
Oh, these are just before planets formed. It's just rings around a forming sun.
Okay.
This is just the debris cloud. So this
Right.
is the stuff that's forming planets.
Yes.
Oh.
And this is one that shows it where they are in a star forming region.
Oh. Interesting.
And this is in planet forming region in the Taurus cloud. I'm not familiar with that name. I assume it's in Taurus, but
This is that big molecular complex that covers parts of Orion and parts of Auriga too, because you can see
Right.
there's those other constellations popping up.
So pretty much all of the systems go flat. They all have a disk, don't they? None of them look like atoms ever. Can't be done.
No,
Unlikely.
and that atom you're referring to is a Bohr atom, which was a schematic to represent energy levels. It was not to mimic or illustrate what an atom looks like, and they don't look like that.
So atoms might look like this. They're flat disk. They're
No,
plates.
no.
An atom, a hydrogen atom with one proton and one electron. The electron is a sphere around the proton.
Right.
So it's not an orbit.
It's not an orbit. The electron is smeared out over the whole sphere.
It's an orbital.
Yeah.
But sometimes they merge with a proton and become a neutron, don't they?
It takes a lot of energy, but yeah.
It's an ongoing process.
A bare neutron by itself is unstable and pops back apart into a proton, an electron, and one other thing, neutrino or something. Neutrino.
Which telescope took these pictures? Do you remember?
Yeah, it's the VLT.
It's an array. It's an array.
In Chile, it's an array.
Well, then you would think if they can take these pictures of a developing stellar, they could get a fixed, a system of exoplanets. Except they can't see them, but they're too tiny by that time, by the time they form planets, aren't they?
Yes.
Although we have images of exoplanets, multiple exoplanets around a star, taken by Hubble.
You can actually see a planet?
Well, you see a dot.
God, amazing. Okay. So we just got to hang around and let them slowly develop into planets and then civilization and eons.
We'll be gone by the time these become planets.
Oh, really? I was hoping it would happen in my lifetime, gentlemen. Well, look, we've run out of time, and this is awesome. Anything we missed, we'll put on a future agenda. Okay, Mr. President?
Yep.
And okay. I want to thank you as we just completed our 160th program. We're deep into two programs into our 4th year of the Santa Barbara Astro Hour, the SBAU Astro Hour. And it was an honor to chair for you Saturday night. It was a regret, of course.
Thanks for doing that.
Yeah, all right, no problem at all. And too bad we had such a dark sky and had to cancel Star Party. Coming up is Westmont Telescope Night next Friday, right, Chuck?
Yeah, this week is busy. Telescope Tuesday, tomorrow night.
Right.
Looks like it might be cloudy for that. Then Monroe School, then Hope School, then Westmont, both Friday and Saturday.
And in 3 weeks, gentlemen, somehow we're going to figure out whether we meet at the April 8th Eclipse event, which is going to be where? Camino Real or at the museum?
Camino Real Marketplace.
Okay. Some of you may want to go out there. Is that what I've heard, that we could broadcast from there? Jerry?
Oh,
Chuck?
you want to? I don't know what the internet situation is.
We got 3 weeks, and then we've got a switched Friday night general meeting to Friday, the 12th of April. Our speaker will be Dr. Carey of Cerritos College, taking on the Drake equation.
Citrus College.
I wrote down Cerritos. You're right. I must grow a lot of oranges down there.
Wash it out.
All right. Well, look, we'll gather around the old Zoom lens again next Monday morning, gentlemen. Thank you. As Chuck always likes to say.
Thanks, Jerry. Thanks, Ron.